you guys, this is Mrs. Bolin here with your notes for section 8.3, where we're going to be learning how to solve systems of equations using elimination. So much like what we did yesterday, we're going to be solving using algebra, but this is a little bit different strategy and one that you guys might like better, you might like worse, just another tool for your tool belt, you guys. Okay, so the warm-up, pretty easy today. We're going way back to one-step equations, what we did at the very, very beginning of the semester. So let's go ahead and solve these quickly and move on to our new learning. So as you remember, the way that we get rid of a -8 is we do the inverse operation, and this is a subtract 8, which is the same thing as adding a -8, but right now we're going to think of it as subtraction. The opposite of subtraction is addition. So when we add 8 to the subtract 8, those are inverse operations, they cancel. So we get x is equal to 15. All right, and the reason we're doing this is because we're gonna be using a lot of just regular algebra solving equations for this whole unit, you guys. Okay, question number 2. The inverse operation of addition is subtraction. So I'm gonna subtract 12 on both sides. And those ones are going to cancel. So I get x is equal to -7. Okay, question number 3, the inverse operation of multiply, which is what I have here. Anytime a number touches a letter, it means multiplication. So I'm going to do division. And the way that I show division in algebra is with the fraction bar. Please, please, please do not write the little line with the 2 dots. Don't do that. In algebra, we show our division with a fraction bar. And I have to divide by whatever is being multiplied. So if you guys notice here, I used opposite signs, here opposite signs, because those signs represented the operation, okay? The operation was multiplication, so the opposite of that would be division, but I need to use the same sign in order for it to cancel, okay? So I get x is equal to -5. Same thing here. Don't skip it just because it's a fraction, okay? The fraction just means divide by 7. The opposite of divide by 7 would be times by 7. So you're just going to put times by 7 on both sides. And in algebra, we show our multiplication using parentheses. Do not write an x, okay? Because that looks like the x that we're solving for. Do not write a little dot because sometimes that looks like a decimal. Go ahead and write the little parentheses. I know it's extra writing, but it will help you to remember what in the world is going on there, okay? So times by 7 and divide by 7 cancel each other out. I get x is equal to 21. All right, hopefully you had those all right. Hopefully you tried them before watching the video, okay? As you guys are working through the notes, you should try to do it just like how we're in class. Try it first and then check your answers, okay? That way that you can make sure that you're learning. All right, I'm gonna go ahead and skip over the notes right now. You guys can use those as a resource and go back and learn them. Go back if you have any questions as you're learning, but I'm going to go through the problems and kind of teach you, okay? So remember, in the problems that we did above, we know that we can add or subtract anything to both sides of an equation as long as we're doing the same thing to both sides, okay? As long as I'm giving it something that's equal on both sides. So if I'm adding 5 to one side, I add 5 to the other side, and I stay balanced, okay? If I subtract 5 from one side, I have to subtract 5 from the other side to stay balanced, okay? So knowing that, I know that this is equal to -4, okay? So I can put a -4 on both sides, or I could put a -4 on this side and a -x plus 2y on that side because I know that these are equal to each other. So I'm gonna add those on both sides knowing that they are equal, okay? They don't look exactly the same, but they have the same value, okay? So on this side, I like that this has x's and y's because that creates like terms over there. On this side, I like that it's just plain numbers because those are alike and I can combine them, okay? So even though these are different in the way they look, they are equal in value. Just like all of you guys, we all look different. We're all equal in value as people. These ones are equal in value even though they look different, okay? So a positive x and a negative x, what happens to those? They cancel, okay? The x's are eliminated. This method is called the elimination method because it eliminates one of the variables, okay? So now I'm gonna put the y's together. So I have negative 6y and positive 2y. So I get negative 4y is equal to positive 4 when I combine those sides. And then I'm just going to divide by negative 4 on both sides. So y equals negative 1. Now remember though that if I'm trying to find the ordered pair, I have to now take this value, plug it into either one of those equations. It doesn't matter. I'm just going to plug it into the top, but you could plug it into either one. You'd get the same answer. We have to find x and y and write our answer as an ordered pair. We have half of that. Now I'm going to plug it in. So I'm going to write the x minus the 6, but the y is stuck to it. I already know what y is. Y is negative 1. And then I'm going to write equals 8. So I have x, a negative times a negative is a positive 6 equals 8, minus the 6 on both sides, so x equals 2. My answer then is 2 comma negative 1. Okay, so we could solve this using substitution, what we did last time. We would have to get one of these letters by itself, but this elimination method, when things are kind of lined up in standard form, it's really nice when you could just cross them off, right? It's my favorite. Okay, so let's look at the next one. We're gonna try that again, but making sure that we're looking at like terms, okay? Because what's on both sides of this is equal, I can just add these sides up and add those sides up. Okay, remember, they look different, but they're equal in value. All right, so I'm going to go ahead and go 7x's, take away 6x's is 1x. Over here, you have to be careful because they're not really lined up. Okay, so I'm going to start by putting the y's together. If I have a negative y and a positive y that I'm adding together, those are opposites and they're going to cancel. If I have a 17 and take away 20, that leaves me with negative 3. Okay, I'm halfway done. I already found what x is. Now I need to go back and plug that in and get what y is. I'm going to go ahead and plug it into the second equation. Just because y is positive, you can plug it into the first one. Doesn't matter. You'll get the same answer. So I'm going to go negative 6, and then instead of the x, I know what x is equal to. It's negative 3, so I'm going to plug that in, equals 17 plus y. And remember, even though we canceled those out to get here, we're going back to the original equation that we had, okay? So then I'm going to go negative 6 times negative 3 is positive 18. If I want to get the y by itself, I need to get rid of that positive 17. So I'm going to subtract 17 on both sides. So I'm going to get 1 is equal to y. My answer is written as an ordered pair with the x value and then the y value, okay? So now, I know you guys are thinking, we're just going to keep adding these up and adding these up. I'm doing this in pencil just so that you guys can see what's going to happen on this because, okay, just track with me. So now, if I add these up, I would get negative 20x, and then I would get positive 3y, and I would get 21, take away 19 is 2, okay? Did anything get eliminated? Are the x's gone? Are the y's gone? No. So what we need to do is think, what other things could we do to one of those equations to make it so that it would cancel? Okay, and there's a couple of options here, but we know this didn't help us at all. It only helps us if the x's cancel or the y's cancel. When I have both of them, I can't solve that. That's got 2 different letters. Okay, so I'm going to erase that. That's why I wrote it in pencil, because even though it's fun to just keep adding things up, this one we have to do something else to it first. What I'm going to say is, well, if this had a 4 right there, I would have a negative 4y and a positive 4y. So I know that I am allowed to multiply by 4 as long as I do it to both sides of the equation, okay? So now I'm going to distribute the 4 to everything on that top equation, and then we're going to look at it again, okay? So I'm going to draw a little arrow here. So 4 times negative 15 would be negative 60x. 4 times y would be negative 4y. 4 times 21 would be 84. Now I'm going to write this one just right underneath. Negative 5x positive 4y equals negative 19. And we're going to see what happens now. Now I know that my y's are going to eliminate. Okay, it's only helpful in the elimination method if something is actually eliminated. Okay, so now I'm going to put negative 60x, negative 5x, so negative 65x is equal to positive 65. So then I'm going to divide by negative 65 on both sides, so I get x is equal to negative 1. Now I'm going to plug it back in. I think I'm going to go for the top equation. You could go for whatever one you want. So I'm going to plug in the negative 1. So I'm going to go negative 15. Instead of x, I'm going to write negative 1. Then there's a minus y and then equals 21. Remember, we're going back to the original equation just because the numbers are a little bit smaller. So I have positive 15, take away y is equal to 21. I'm going to subtract the 15 on both sides. So I get negative y equals positive 6. I'm going to divide by that negative 1, so I get a plain y equals negative 6. But again, that's not my final answer. Sorry, I shouldn't have drawn a box around it. My final answer is the x value and the y value. Okay, I'm going to unbox that one because that was just part of my answer. My final answer is the ordered pair. Okay, well, now you guys are looking at number 4, and that's like 3 can't go into 7, 7 can't go into 10. So, and they're all positives. They wouldn't cancel, right? We need one positive, one negative. So what I'm going to have to do on this one is multiply both equations. Okay, so I can either do this one times by 7 and this one by 10, but I want to keep the numbers a little bit smaller. So I know 3 and 7 both go into 21. So I'm going to multiply this top equation by 7. And then I'm going to multiply this bottom equation by negative 3. Okay, on both sides. All right. Oh, sorry. I'm going to draw little arrows. I'm going to put my new equations over here, and then I'm going to add them up. Because if I add them up like this, nothing's going to cancel. Okay, so now I have to distribute the 7. So I have 70x plus 21y equals negative 28. Then I'm going to distribute the negative 3 down here. So I've got minus 21x minus 21y equals negative 21. Okay. So now we're going to add those together. So we want to check, did something get eliminated? Yep, the y's got eliminated. Yes. Okay, so now I have 70 take away 21, which is 49x. And then on this side, we get negative 49. So I'm going to divide both sides by 49. So I get x is equal to negative 1. And then I'm going to plug it back into either equation. Let's just go for this bottom one right here. So I'm going to write 7 times 1, negative 1, plus 7y equals 7. So I'm going to say that's negative 7 plus 7y equals 7. I'm going to add 7 to both sides, so 7y equals 14. When I divide by 7 on both sides, I get y is equal to 2. Oops, look at you guys, look at me. I'm going to start boxing all of these answers. It just feels like we should be done, right? So now I'm going to write them in alphabetical order, negative 1, positive 2. You guys, I know these are really long problems. I know there's a lot of steps, but hopefully the more we practice them, the more you can kind of start to see the patterns here, and the steps, you won't have to look back to your notes. You'll just know them, right? Okay, one more for number 5 here. Again, we do not have anything that's going to cancel, right? So we're going to have to multiply both equations. So you could go for the x's, multiply the top by 10 and the bottom by 8. I'm going to go for multiplying by the 3 and the 4, making sure that I'm going to do this one, I think, by negative 3 so that I could get a negative 12 there. And then I'm going to do this one by positive 4. Okay, so here's our new equations. And you don't have to write it on both sides like I did. You could just put the whole equation in parentheses, but sometimes when that happens, you forget to multiply it by the other side. So that's why I wrote it twice there. So we have a positive 24x, we have a negative 12y, and we have a positive 12. On this side, we have 40x plus 12y equals 4 times 13. That would be 40 plus 12, which is 52. And now we're going to add those up. So does something get eliminated? Yes, our y's get eliminated. So that's how we know this is the elimination method. Okay, so we're going to add those up. We get 64x is equal to 64. I'm going to divide by 64 on both sides. So I get x is equal to 1. Now I'm going to plug that back in. I'm going to go for this bottom one just because everything's positive, but you could plug it into either equation. So I'm going to go 10 times 1 plus 3y equals 13. The 1 I got from there, I just put in for the x. Okay, so I know what x is. Instead of writing an x, I'm going to plug in the 1. 10 times 1 is 10 plus 3y equals 13. Take away the 10 on both sides, so 3y is equal to 3. And then divide by the 3 on both sides, so y is equal to 1. The answer to this one is 1, 1. Kind of looks like a smiley face there, minus the smile. All right, question number 6. The sum, remember sum just means plus, of two numbers is 23. So I'm going to write x plus y equals 23. I have two different numbers. I know that if I add them up, I get 23. Their difference is 3. Okay, I know that if I subtract them, I get 3. What are the two numbers? Well, look at this one, you guys. What's going to happen? The y's are going to get eliminated, so I know I can just add them up. So x plus x is 2x. 23 plus 3 is 26. Divide by 2. So x is equal to 13. Well, I know that I still have to find the other one. So 13 plus something equals 23. Well, I know that y would have to equal 10 to make 23. And if I subtract them, I do get 3. So my two numbers are 10 and 13. Okay, now on to the warm-up, or sorry, we did the warm-up, we did the notes, we did the practice problems. Now we're going on to your homework. We're just going to do the odd problems for the sake of time and because you guys need something to practice on your own too. All right, question number 1. These ones are set up super nice. They're going to eliminate for us. So remember that x's cancel. 3y's and 2y's make 5y. 17 plus 8 is 25. Divide by 5 on both sides, so y is equal to 5. I'm going to plug that into the top one just because they're positives. So I'm going to say x plus 3 times y, well, I know y is 5, equals 17. So x plus 15 equals 17. Take away the 15 on both sides, so x is equal to 2. So my answer then is 2, 5. Remember to pause the video if I'm going too fast for you. Question number 2, same thing. You're going to add them up, see what you can cancel, and then figure out the rest of it. Keep working on that one on your own. All right, question number 3, same thing. Here's my line where everything's equal. I'm going to add them up because this value is the same as that value, even though it looks different. I know that those ones get eliminated. So now I'm going to say, what do I have left? 9 x's, take away 1 x. It doesn't subtract the x off of there. It just means I've got 9 of them and I'm taking 1 away. So I have 8 x's left. And then I'm going to add those up because they're both positive. So that equals 40. Divide by 8 on both sides. So x is equal to 5. Now we're going to take that value and plug it in. I'm going to go ahead and use the bottom one. So I'm going to plug that in. So I'm going to say negative 5 plus 3y is equal to 19. I'm going to add 5 to both sides. So 3y is equal to 24. Divide by 3 on both sides. So y is equal to 8. So my answer then is written as an ordered pair 5, 8. Oops, sorry you guys, I wasn't paying attention. All right, question number 5. This one we cannot just add, and 5 can't go into 7, 7 can't go into 5. So what I'm going to need to do is multiply the top one by 7. And then the bottom one I'm going to need to multiply by 5. But in order for things to cancel, remember we need one positive and one negative. So I'm going to multiply the bottom by -5. All right, so here's what we get. We get 35x plus 49y is equal to 49. And then on the bottom, I get minus 35x, and then I get minus 25y, and then I get equals -25. Sorry, I didn't leave much room on that one. Hopefully you guys can still see. All right, so then the x's are eliminated. 49 take away 25 is 24y equals 24. Divide by 24 on both sides. So we get y is equal to 1. Now I'm going to plug that back into either one. I'll just use the top one. So we have 5x plus 7. I know what y is. Y is 1. So I'm going to say 5x plus 7 equals 7 minus the 7 on both sides. So 5x equals 0. And then divide by 5, so x is equal to 0. So my answer then would be 0, 1. Okay, that kind of looks like the Monopoly guy, like with a monocle. Like. All right, we're going to skip number 6. You guys can do that one. And just multiply by a -2 on the top. Should be super helpful to you. And then they should cancel. And then we're going to look at question number 7 really quickly. Okay, this says one admission to an ice skating rink costs X dollars, and renting a pair of ice skates costs Y dollars. Your friend says she can determine the exact cost of one admission and one skate rental. Is your friend correct? Okay, well, we remember that the admission costs X and the skate rental costs Y. So we could say 15X plus 10Y equals 190. And then we could put an X there and a Y there. So we know 3X plus 2y equals 38. Well, if I want one of these to eliminate, I would have to multiply by -5. Okay, so this one on the top stays the same, 15x plus 10y equals 190. And then I would get -15x minus 10y equals, I think that's -190. Yeah, -190. And so is this going to be very helpful if everything eliminates? We just got 0 equals 0. Okay, so your friend is not correct. Ordinarily, if we had 2 different points, yes, that would be correct. But because this one is an exact multiple of the original, of the smaller numbers, and everything cancels out, not helpful. Okay, so your friend is not correct. No, because everything cancels. We would need a different point, like if they told us what 4 admissions and 2 skate rentals cost, that would be fine. We would be able to solve for that. But because these ones are both a factor of 5, everything cancels and we don't really have any new information. Okay, so you guys are going to look at question 8 on your own, and that'll do it for 8.3.